Good morning. Chapter 6, Lesson 1 is on page 264. We're starting a new chapter. We're going to be factoring polynomials instead of multiplying them using FOIL or the box. We're going to be going backwards. Factoring is the opposite of multiplication. Factoring is the opposite of distribution. Let's try number 9 first. It says 12a cubed b to the fourth, and we're going to have to, I think, find three factorizations for each of these monomials. So let's start with the 12 and the a cubed and the b to the fourth. So I think 12 we can make as 2 times 2 times 3. A cubed is just a times a times a. And b to the fourth is b times b times b times b. Now when we have to factor these, we're just going to sort of mix and match and see what we can come up with. And we're free to use any of these factors that we'd like. So I might choose for one of my factors, I might choose 2a and b. So one of my factors would be 2 times a times b, 2ab. Maybe another factor might be, I might want to use the entire 12. 12, maybe use a and maybe use b, b, and b. So my second one might be 12 a squared b to the third. And all of these are factors of 12a cubed b to the fourth. A third one might be, I really do like 2 and 3, and I want to use all 4 b's. So my third one might look like 6b to the fourth. And I'll pick off one of these a's to use as well. A. So different factorings are possible. There's lots of modes that lots of different ways you can come up with this. Just mix and match, and you can come up with lots more other than just the 3 that I have. Let's try number 41 on page 264. A little bit more complicated, but again, all we're going to do is write these out and see what we can come up with. We want to see what is common when we're factoring, what's common with all of these. So in the beginning, it might be easiest just to write this out as 2 times 3 times m times m times m times n times n times n plus 3 times m times m times m times n times n. I know this is tedious, but you'll see what happens. M times m times n times n. Wow, lots of work. Let's stare at this for just a second. Let's see what we have in common all the way across. In each of the 3 terms, we have to have the same things appear. Well, m, another set of m's, another set of m's. How many n's can we take out? I think there's a set of n's here, set of n's there, there's a set of n's there. We can't take out the 2 or the 3 because nothing appears in this third term way over here. So what we're going to factor out is m squared n squared. I'm taking it out. I'm removing it from each of the terms. And then what's left here is 2 times 3, or 6m n, plus, if I take out the m squared and the n squared, I'm left with 3m plus, and if I took out those m squareds, n squareds, I'm left with, remember, 1. I could put my invisible 1 back here if I needed to. So when I take out the m squared, n squared, I'd be left with m. Kind of make it neater. M squared, n squared times 6mn plus 3m plus 1. That's it for today. See you all tomorrow.